Hi students, good night to all of you. So students, all of you know we are on the chapter which is named as magnetic effect of current, and we just completed one lecture, that is the introduction part. And what we will learn from last lecture? In last lecture, we will learn that the Biot-Savart law, the expression of magnetic field for a current carrying wire, for a current carrying conductor. Now today we will derive the expression of magnetic field. You see the heading, the magnetic field due to a long state current carrying conductor. Today we will derive the expression of magnetic field for this long state current carrying conductor. Okay, so once again welcome to your favorite channel TKG Physics classes. Now open your copy and write down the notes. So first of all, you see this diagram. At first you draw it. Here XY, this is an infinite current carrying conductor. Okay, and you have to find out the magnetic field. Suppose at point P, all of you know a current carrying conductor produces a magnetic field surrounding its region. We just completed in your first lecture. Okay, so here you have to find out the magnetic field at point P due to this current carrying conductor XY. Okay, and this is infinitely long. Now for doing that part, at first you have to draw this one, P to Q. There is the perpendicular distance between this conductor and which is named as A. This distance is named as A, and you have to consider the small current element. We told that the Biot-Savart gives the expression of magnetic field due to a current element. Okay, so here I am considering this one, the del L, the small current element del L, and suppose this point is, this one is L, O to Q, L, so this is the direction of del L along the direction of current, and this is the position vector. O to P is represent position vector which is named as R, and the angle between del L and R is named as theta, and suppose this angle is named as alpha. So first of all you write down this value here. OP is called position vector R, del L is a current element, and QOP is equal to theta, QOP is equal to theta, and OPQ is equal to phi. Suppose OPQ, this angle is equal to phi, and magnetic field. So according to Biot-Savart law, we can write down the expression of magnetic field here. So write it. According to Biot-Savart law, the expression of magnetic field at P, that is equal to dB is equal to mu naught by 4 pi I dl sine theta by r square. This is a general expression. Okay, now we have to simplify here. Okay, now you write from triangle OQP, what we can write? OQP, this angle is theta, this angle is phi, and this angle is 90 degree. So write it, theta plus phi plus 90, that is equal to the sum of three angles, that is 180. So from here you can write theta plus phi, that is equal to 180 minus of 90. So this one is theta plus phi, that is equal to 90 degree. So you can say theta is equal to 90 degree minus phi. Okay, here at first you have to write theta in terms of phi. Question is why? You have to find out the total magnetic field, the magnetic field at point P due to the conductor XY. So you have to find out, for finding this part you have to convert it integration with limit phi 1 and phi 2. So from this value theta to, you have to convert phi. Okay, now So what will be the value of sine theta? Therefore for sine theta, this one will be, you see, sine, for the place of theta you write 90 minus phi, 90 minus phi, so this one will be cos phi. Okay, so in the place of sine theta you will put cos phi. Now you find out the value of cos phi from this triangle OQP. So write it down. From triangle OQP, the value of cos phi, that is equal to, here this is phi, so this angle is the base A, this side is base and this side is hypotenuse, that is OP is represent hypotenuse, so cos, that is equal to A by R. So from here you can write R equal to A by cos phi, and 1 by cos phi, that is sec phi, so sec phi into A. So in the place of cos phi you can write, sorry, in the place of R you can write A sec phi. Similarly from this triangle you find out the value of tan phi, write it, tan phi, tan phi, so this is phi, perpendicular, that is L, and base, that is A, so tan phi, that is equal to L by A. So from here L equal to A tan phi, but here you see there is a del L, so differentiate it. So by differentiating, this one will be del L and this one will be A. Differentiation of tan phi, that is equal to sec square phi into d phi. Okay, now putting this value, suppose this is equation 2, this is our equation 3, and this is our equation 4. Now putting equation 2, 3 and 4 in equation 1. Okay, first you write down this one, you can take a screenshot. Okay. Putting this value 2, 3 and 4 in equation 1, then you write it. So putting equation 2, 3 and 4 in equation 1, you see, therefore dB is equal to mu naught by 4 pi I del L, that means A sec square phi d phi, A sec square phi d phi, that is sine theta, and sine theta, that means cos phi, so this one is cos phi divided by R square. You see R, that is equal to A sec phi, so R square, that means A square sec square phi. Okay, now simplify it, so dV is equal to mu naught by 4 pi, you see, sec square phi cancel out, 1A cancel out, so this one will be mu naught by, okay, this one will be mu naught I by 4 pi A, mu naught I by 4 pi A, and there is cos phi d phi, cos phi d phi. So this is the expression of at point P in terms of phi. Okay, at first you have to write down the general formula, then you have to convert this formula in terms of phi, because for finding the total magnetic field, integration will be phi 1 and phi 2. Okay, to convert the value of dV in terms of phi. Okay, now you see, when we use this value of phi, that means we are finding the value of magnetic field for this length. When this phi will be increasing in this way, when the phi will be increasing in the downward direction, that means when phi will be increasing, the value of magnetic field will be also increasing like this way, this length. Okay, now if we consider this angle, suppose this angle is phi 1, so when you consider the angle phi 1, you will get the magnetic field for this length q2x. Similarly, when you use this angle phi 2, that means you will get the magnetic field for this length q2y. So when we use the integration value, that is lower limit phi 1 and upper limit phi 2, but lower limit not phi 1 minus of phi 1. Why? Because you see this one is the negative direction, downward, and this one is the upward direction. So here phi 1 is negative. You can also take phi 2 is negative, then you have to write phi 1 is positive. Okay, so I am writing here phi 1 is negative because this one is the downward direction, and phi 2 is positive, that is because this is the upward direction. So taking minus phi 1 to phi 2, we will get the total magnetic field due to this total wire, total conductor xy. When you use this angle, you see, when you use this angle, you will get the magnetic field for this length. When the angle is increasing, the length of the magnetic conductor is also increases. So total magnetic field, write it, total magnetic field at P due to the conductor xy is given by B, that is equal to integration of dV, and the limit will be minus phi 1 to plus phi 2. That means integration minus phi 1 to plus phi 2, and you know the value of dV, this one, mu naught I divided by 4 pi a cos phi d phi. Okay, now you see this value is constant, mu naught constant, I current flowing, that is constant, 4 pi, and a, this length is also constant. So this one will be outside, mu naught I divided by 4 pi a integration minus phi 1 to phi 2 cos phi d phi. Okay, now you have to integrate this part, so by integrating, this is the magnetic field B. So B will be, you see, mu naught I by 4 pi a cos phi d phi integration, that is sin phi. So this one is sin phi, and the limit, that is minus phi 1 to plus phi 2. Now putting the limit, that is mu naught I by 4 pi a sin, use this value phi 2 upper limit minus of, then a lower limit, that is minus phi 1. So this one will be plus phi 1. Okay, so this is the general expression, of magnetic field at point P for this conductor xy, for this wire xy. Okay, and this is the general expression. You see here phi 1 is the downward angle and phi 2 is the upward, this angle. Okay, now we will use some special condition, then we will find out what happens, what will be the magnetic field for these cases. Okay, so write it for first case. And one thing important thing here, what is the direction of magnetic field here? You see, this is the direction of del L and this is R. So you have to use screw rule, that is del L, here you use del L cross R, like this way, del L cross R. So this will be going inward, so here direction inward, which is represented as cross. Okay, now case 1, suppose the conductor, that is xy, is infinitely long, and the point P is at middle. Okay, this xy is infinitely long, like this way, like this way, and P is placed at middle point here. Now what will be the expression of magnetic field? You see, when the wire length is, okay, remove this part, suppose this is point P, when the wire length is this one, so this is the angle, this one is the angle, that is value of phi 2. Now the length of this wire is infinitely long, that means when the wire length is this one, this is the angle is increases. As length of the wire increases, the angle is also increases. So when the wire length is this one, the angle length is also increases. So when the length of this wire is infinitely long, then the value of phi 2 will be nearly equals to what? 90 degree, or you can say pi by 2. You see, for this length the angle is small, for this length angle is increases, for the length increases angle increases, length increases angle increases. So for infinitely long wire the angle will be 90 degree. So here in this case this one is also same. So for this case phi 1 and phi 2 both the angle will be 90 degree. Now use for here. So B will be mu naught I by 4 pi a sin 90 plus of sin 90, and you know the value of sin 90, that is 1. So 1 plus 1, so this one is 2. So this value will be mu naught I by mu naught by 4 pi 2I by a. You can write this value also. Okay, and now simplifying you can also write this one, that is mu naught I divided by 2 pi a. So this is the expression of magnetic field, and this expression happens when the length of the wire is infinitely long and the point P is at the middle, that is perpendicular bisector at the middle point. Okay, so this is the expression. You can use this expression also. When you use mu naught by 4 pi, you always know the value of mu naught by 4 pi. Okay, so this is the best way out for remembering this part. There is mu naught by 4 pi 2I by a, and you know the value of mu naught by 4 pi, the rest 10 to the minus 7. Okay, now case 2. Case 2, write it. Suppose xy is infinitely long. Suppose xy is infinitely long and P is lies at near y or x. You can write, okay, at first you write P is lies near x, or you can write y. That means in that condition, you see the wire is infinitely long, but this point is x, P is placed here, P is placed here. So for this condition, you see infinitely long, so this angle, that is the value of phi 2 will be 90 degree, but the point P is lies near x, so the value of phi 1 that is 0. And same way, when the point P lies y, in that condition the value of phi 2 will be 0, but the value of, you see, perpendicular, this one infinitely long, so this angle, that is phi 1, will be 90 degree. So write it. For near x, the value of phi 1, that is 0, and phi 2 will be 90. So the expression of B will be, you see, mu naught I by 4 pi a, mu naught I by 4 pi a sin phi 2, that is 90, plus sin phi 1, that is 0, and you know sin 0, that is 0, and sin 90, that is 1. So this one is mu naught I by 4 pi a. So for this condition, the expression of magnetic field will be mu naught I divided by 4 pi a. This is the expression of magnetic field when the wire is infinitely long and the point P is lies near end x or near end y. Okay, so mu naught I by 4 pi a when the point P lies near end x and y, and when the point P is in the middle and the wire is infinitely long, in that condition B is equal to mu naught I by 2 pi a. Okay, now write another case, that is case number 3. Okay, write it. For case number 3, you consider a finite length. Case 3, xy is finite length L, and P is lies at middle. You see, so for this case our figure will be like this way. There is a finite length and the point P is lies middle. So this length, total length L, that is up to this portion length L by 2. Okay, this one is del L, this angle is theta, and this length is A, you know, so this angle, this side will be root under a square plus this L by 2, L by 2 the whole square. So at first you find out the value of sine phi. This angle is phi, you know, this angle is phi. So sine phi, that means perpendicular by hypotenuse. This angle is base, perpendicular, L by 2, and hypotenuse, that is this one, root under a square plus L by 2 the whole square. So this one will be, on simplifying, L divided by which one? Root under, this one will be 4 square plus L square. Okay, now use general expression, that is B equal to mu naught I by 4 pi a, there is sine phi 1 plus phi 2. Here you see the point P is at the middle, so phi 1 and this value is phi 2 will be equal. Phi 1 is phi 2, that is equal to phi. So you know the value of sine phi. This one is sine phi and this one is also sine phi, that is 2 into sine phi. So write it mu naught I by 4 pi a, and this one is 2 into sine phi. Now putting the value of sine phi, that is mu naught I by 4 pi a, 2, and the value of sine phi, see, L divided by root under 4 square plus of L square. Now simplify. So the value will be mu naught I L divided by, that is 2 pi a root under 4 square plus L square. So this is case number 3. Okay, so this is all about the magnetic field due to a long straight current carrying conductor. Now you see the expression of magnetic field B, which is equal to, for first case we find this value B is equal to mu naught I by 2 pi a, and for second case we find B is equal to mu naught I divided by 4 pi a. Now you see the variation of B with A, the magnetic field, variation of magnetic field with this separation, perpendicular distance from this conductor from the point of observation. And now if we draw a graph from magnetic field versus A, so the graph will be like this way. Okay, and how we will find out the direction of magnetic field? All of you know screw rule, or you can use this one, the right hand plumb rule. This one is a conductor, current is flowing in this way. Now you use your plumb right hand, and this finger is give the direction of current, then the direction of your other finger, you see the direction of other finger in this way is gives the direction of magnetic field lines, or you can also gives the direction of magnetic field. Now when the current is flowing like this direction downward, so you have to use your hand like this way, so your other finger gives this direction, that means the direction will be here this way, and this one is gives the also the direction of magnetic field line. Okay, now we will solve some numericals related to this topic. Okay, so this is the problem. At first write down, you see problem 1. In problem 1, the magnetic induction at a point P, which is at a distance of 4 cm from a long current carrying wire, is 10 to the power minus 3 Tesla. That means magnetic induction unit given Tesla. So you see this one is named as magnetic field also. So magnetic field, suppose B1 is given 10 to the power minus 3 Tesla, and the separation given, you see this separation, this is P point and this separation is A. Here A value given, so for first case you write A1, that is 4 cm. Okay, this value is in CJ system. Okay, now what is the magnetic induction at another point? That means you have to find out B2 for second case, and at a distance of 12 cm. This separation A is given for second case, that is 12 cm. So what is the condition? You know the expression of B, that is mu naught I divided by 2 pi a, the special case number 1. So for first case, that is B1, the expression will be mu naught I divide by 2 pi a1, and for second case b2, this one will be mu naught I divided by 2 pi a2. So b is directly inversely proportional to a1, so b1 by b2, this one will be mu naught I divided by 2 pi a1 into divided by b2, so this one will be 2 pi a2 divided by mu naught into I. Mu naught I, 2 pi, all are cancel out, so this one will be a2 by a1, that is b1 by b2. So you have to find out the value of b2, so b2 by b1, this one will be a1 by a2, therefore from here b2 will be a1 by a2 into b1. Now putting the value, that is b2 is equal to, here value of a2 that is 4, a1 that is 12 into b1 that is 10 to the power minus 3. So this one is 1 by 3, and you know the value of 1 by 3, that is 0.333 approx into 10 to the power minus 3 Tesla. This is the answer. Okay, so this is the first question. Two cases given, you have to compare it. Now second is important, theoretical problem students, very important. Use Biot-Savart law to obtain an expression for the magnetic field at the center of a coil, but the coil is bent in the form of a square. That means you have to find out the magnetic field at the center of a square of side 2a and the square carrying current I, and you have to use Biot-Savart law. Okay, very important part. Listen this part is carefully. Okay, so our second problem, at first draw the diagram. Problem 2, a wire, a coil is bent into the form of a square, this is a square of side 2a carrying current, suppose carrying current I, you see carrying current I. Now you have to find out the magnetic field at the center. So this is our point P, observation point. Now at first you find out the magnetic field at point P due to this side. Okay, now you see this is point P, this is A, this value is A, there this one will be del L, and del L will be directed this direction along the direction of current. Here current is directed downward, so del L directed downward. Now you use the formula, that is general formula, B mu naught I divided by 4 pi A sine phi 1 plus of sine phi 2. Here P is at the middle point, so phi 2 and phi 1 both are equal, and which is equal to phi, and here you see this value angle is 90 degrees, so phi, both phi value is 45 degree. Okay, so this one will be mu naught I divided by 4 pi A sine 45 plus sine 45. Sine 45, that is 1 by root 2 plus 1 by root 2, that is mu naught I divided by 4 pi A 2 by root 2. Now simplify it, 2 by root 2 multiply 2 and you multiply to this one, so this one will be mu naught I divided by 4 pi A, this value is cancel out, that is 2, root 2 mu naught I divided by 4 pi A. This is the expression of magnetic field. Suppose this one is named as B1, for this length A, B, C, D. For this side, for the side AB, the expression of magnetic field which is named as B1, and the value is root 2 mu naught I divided by 4 pi A at the center. Now you see each length has the same side, that is each side has same length, that is 2A, and you have to find out the magnetic field at point P. So for each side the expression of magnetic field will be equal. For each cases phi 1 and phi 2 will be 45 degree. So the total magnetic field B will be just multiply with 4. Okay, 4 side, so multiply with 4. So this one will be root 2 mu naught I 4 divided by 4 pi a. 4 cancel out, that is root 2 mu naught I divided by pi a. This is the expression of magnetic field at the center of a square. Okay, so this is the theoretical part. Suppose your problem given the square of side 20 centimeter. So side 20 centimeter, that means here you have to use the value of a 20. Current suppose given flowing, that is 15 ampere, so you have to use the value of 15 here. Okay, like this way. Now problem 3, this one is also interesting problem and important problem. Okay, at first you read it. Is cube given, a cubical box given of side, each of side 20 centimeter. Here current flowing, that is 200 ampere, current flowing, that is 200 ampere. A straight current carrying conductor which is passing through this cube, there is a hole, so this straight current carrying conductor passing through this cube of current, that is I is equal to 200 ampere. PQ, here the small current element PQ of length 1 centimeter given. Now you have to find out magnetic field at point A, at point B, at point C and at point D. Now condition given, the point A, B, C are the center of the faces of the cube and D is the middle point of one edge. D, middle point of the one edge. Okay, so at first you write find out the magnetic field at point A and B. Okay, before going to that part, before going to that part, at first you find out the magnetic field for this current element PQ at point C. Okay, find it. Very important, students. So when you find out the magnetic field at point C, here you see this is PQ, this is PQ, problem 3, and this is point C. This PQ, that means this is the value of del L, current element, and this is point, our observation point C. So this is also the length, that is named as R. So here del L and R is made an angle, what? Made an angle theta is equal to 0 degree, because both are in same line, both are parallel. Okay, you have to find out magnetic field on the same line, on the line of the conductor. So use the expression, general expression, B is equal to mu naught I by 4, sorry, mu naught by 4 pi I del L sin theta by r square. Now see, theta is the angle between del L and r, and here the angle between del L and r, that is 0 degree. So when we use mu naught by 4 pi I del L sin 0 divided by r square, so this result will be 0. So the magnetic field at point C, that is 0, our first answer. Now you find out the magnetic field at point B, A and B, and you know what is the significance of this value? That means A that means on the wire, on a current carrying wire, there is no magnetic field. You see, on a current carrying wire the magnetic field is 0, but surrounding the current carrying wire there is a magnetic field. Okay, now you find out the magnetic field at point A and B. You know the side of each box, that is 20, and this is A, B and C at the center. That means from this length, this is R, and this length and this length, that is half of the side, this is at the center. So this length is 10 centimeter. Okay, so okay, so for second case, find out magnetic field at point B or A. The expression will be same, because both are separated at a distance 10 centimeter. So the magnetic field at point B and A will be formula, that is mu naught by 4 pi I del L sin theta by r square. Now you see mu naught by 4 pi value, that is 10 to the power minus 7, I current flowing, that is 200, del L, the current element PQ, the length that is given 1 centimeter, that means 10 to the power minus 2 meter. The value of sine theta, you see this is del L, this is the direction of del L for this case. This is PQ, so this is the direction of del L PQ, and here a point A, so this is R, so angle is 90 degree, and at point B this is also perpendicular, that is angle 90 degree, so this one is 90 degree, and R square, this R value, that is half of the side of the cube, that is 10 centimeter, 10 into 10 to the power minus 2, there is a square part, so 10 into 10 to the power minus 2 is twice. Okay, now solve it. 10 to the power minus 2, 10 to the power minus 2 cancel out, 0 0 0 0 cancel out, so this value will be, you see this one is 10 to the minus 7, this one will be upper side, so this one will be 10 to the power minus 7 plus 2, so that is 10 to the power minus 5, and there is value of 2, this one is 2, 10 to the power 5, yes, and sine 90, that is 1, so this is the value 2 into 10 to the power minus 5 Tesla, and this is the expression of magnetic field at point A and at point B. Same, because the separation, that is R distance, is equal. Okay, now third case, you have to find out the magnetic field at point D. So for finding magnetic field at point D, at first you have to find out the length from this point, this length, and you see the condition given, D is the midpoint of one of the edge, so this is the midpoint, so this one is 10 centimeter, this one is 10, and this one is 10, this one value 10, so this value is 10, 10 10, this is the hypotenuse. So for finding, okay, so for D point, for D you write the value of R, that is distance, this one and this one, so root of 10 square plus 10 square, so this one will be this one 10 root 2, or you can write this one centimeter, so this is 0.1 into root 2 meter. Yes, 0.1 into root 2 meter. So this is the value of R, this value. Okay, now you use the formula, B is equal to mu naught by 4 pi I del L sine theta divided by R square. Mu naught by 4 pi 10 to the power minus 7, I, that is 200, del L, that is 1 centimeter, that means 10 to the power minus 2, and here sine, you see this angle, this is the middle point, so this angle is 45 degree, sine 45, and R square, that's this one, 0.1 root 2 into 0.1 root 2. Now simplify it. Okay, so this one is 10 to the power minus 7 minus 2, that is 10 to the power minus 9 into 2 into 100 into sine 45, that is 1 by root 2, 1 by root 2, this one is 0.1, so one point will be 0.1, 0.1 root 2 into root 2, this one is 10 and this one will be 10. Okay, root 2, that means 2, so this one is cancel out, and you see this one is 100, this one is 100, so 10 to the power 4, 10 to the power plus 4, that is 10 to the power minus 9, so this one will be 10 to the power minus 5, and there is value 1 by root 2. Check it, this one is 1 by root 2, so this one is 1, okay, this is 10 to the minus 9, this one is 10 to the power 2, 10 to the power 2, that is 10 to the power 4, that is 10 to the power 5, yes, and the value of 1 by root 2, you know, 0.707 into 10 to the power minus 5 Tesla. Okay, so this is the expression of magnetic field at point D. Okay, in this way we can solve find out the magnetic field. I think this part is clear to all of you. Today I am ending here. If there is any problem, tell me in the comment section. Okay, so today I am ending here. Meet you soon in next class. Bye bye.